Hello, Doctor. Today, in behalf of Group 25, we will be delivering our project presentation for the subject Automata Theory, that is CPT 4111. So let's begin by the introduction. Myself, Nafis Aslam, a student of computer sciences, and my metric is 155174.
Hi, I'm Crystal Tan Kari, metric number 151967 from School of Computer Science.
So our title for this assignment of applying automata theory into real life is Modeling and Managing a Student's Discipline with the Use of Deterministic Finite Automata, that is called DFA. So here is the entire outlining of the presentation that we are going to do. I will be delivering the initial parts, the introduction part. We shall cover the motivation and the problem statement and a bit background of the entire project. And then I'll move on to discussing a bit about the automata, its definition, application, and types of automata. And then the literature review, some of the papers that we have explored to understand the topic better.
And I'll be covering the methodology, system design, implementation, and student use case.
Beginning with the topic number 1, that is the introduction of the assignment of the project. So what is our goal, overall goal of this assignment? Our overall goal is to explore and demonstrate how automata theory could be used in the field of education to enhance students' discipline and their academic performance. And why? What is the motivation behind this goal? The main motivation behind this goal is that we know academic success is not just about intelligence or talent. It's more about discipline, consistency, and their study habits. Even I, as a student, often struggle with consistency and discipline. And most of the students would agree to this. That is why we have come up with this. So the problem statement goes like this. The universities and other institutions often struggle to provide a personalized support to the students due to the large number of population or due to their other commitments. And this leaves students a gap to manage their discipline, consistency independently. And this is why this project proposes an idea, a solution using DFA to create an adaptive, real-time feedback system that responds to an individual student's behaviors with the aim to enhance their discipline and academic performance. So that is the problem statement. Moving on to this second part, a bit of background about the automata. That is number topic 2. What is automata? So what actually is automata theory? Automata theory is one of the core fields in computer sciences. It talks or studies about the abstract machines and the computational problems those machines can solve. It has a lot of significance in the field of computer science because it helps us understand how those algorithms function in order to solve those complex computational problems. There are 3 types of automata. Finite automata, which is used for recognizing the regular languages, and then there is the advanced version that is push-down automata. That's kind of similar to finite automata with a stack that recognizes the context-free language, and then the most advanced Turing machines, which can kind of capable of simulating any algorithm of computational world. And talking about the application of automata, it goes into the field of computational linguistics, software engineering, cryptography, and then network security, bioinformatics, robotics, text processing, and many other such fields. Moving on, let's discuss the topic number 3. That is some of the literature review that we have done. We have done with 5 to 6 papers, but here I'll be discussing the major 3 papers that kind of relates to our chosen topic. So the first paper by Odlin, Automata as Science and Technology Artifacts. This paper kind of explored how automata bridges the gap between theoretical concepts in the classroom with practical application in computer science education. The second paper by Shinwei Kar, Adaptive E-Learning using Deterministic Finite Automata. It basically discusses the customization of educational content based on the individual learning pace using automata. And then the third paper by John Uman, Educational Robotics and Automata Theory. It kind of integrates robotics into automata theory to provide practical learning experience in technological education.
Now, I will be presenting to you the methodology of the research. The development of the DFA involved defining states that represent various levels of student discipline. These states include the initial state, where a student has no submissions or irregular attendance. Next is a moderate state, where the student has some submissions and moderate attendance. Lastly is a high discipline state, where the student regularly submits assignments and has high attendance. Transitions between these states are triggered by specific students' behavior, such as completing assignments on time for transition A, missing assignment for transition B, attending scheduled classes for transition C, and missing classes for transition D. This structured approach allows the DFA to accurately model and monitor students' behavior, providing a clear framework for intervention and feedback. The case study of the research is to demonstrate the effectiveness of the DFA-based approach. A hypothetical case study is presented. This case study involved a high school with a diverse student body where the DFA system is implemented to track and improve student behaviors. Here are the sample of scenario where a high school integrates the DFA system with its existing digital learning platform. The system monitors student behaviors such as assignment submission and class attendance. This provides real-time feedback based on DFA states and transition. Next is the system design of the project. Here are the transition diagram for the DFA. The DFA is designed to represent different states of student discipline and consistency. The states and transitions are defined earlier, so from the diagram, we can observe that the students will start at initial state, where a student has no submissions or irregular attendance. When student completing assignments on time or attending scheduled classes, it will transit to moderate state, and if student miss assignment submissions or classes, it will return back to initial states. Here is the system architecture. It consists of Student Management System, SMS, which is a platform where student activities, assignments, class attendance are logged. Next is the DFA engine, where the core component that processes students' activity data, updates states, and triggers feedback. Third is feedback module, where it generates and sends feedback based on the current state and transitions. Lastly is user interface for students and educators to view progress and feedback. The system flow starts with data collection, where the SMS collects data on students' activities. Next, DFA processing, where the DFA engine processes this data to update the student's current state. Third is feedback generation, where the feedback modules generates appropriate messages based on the state transition. Lastly, user notification. The feedback is displayed on the user interface, providing students and educators with real-time updates. There are two types of feedback, which is positive feedback, where it provides encouraging messages such as "Great job on submitting all your assignments on time" for students who transitions to higher discipline states. Second is corrective feedback, where it provides reminders and suggestions for improvements such as "You missed a class today. Try to attend all your classes to stay on track." Next, there are two types of feedback delivery, which is in-app notification and email notifications. In-app notifications provide immediate alert, meanwhile, email notification provides summary of student activities and the feedback. Here are the example of the user interface for the system. Yellow indicates the user has missed a few classes or assignment submission. Green indicates the user has perfect attendance or assignment submission. Orange indicates the user has consecutively missed their classes or assignment submission. Moving forward, we will now discuss regarding the implementation of the system. Additionally, there are two methods to implement the model, which are through software tools and testing. The DFA was modeled using JFL Lab to simulate and test its functionality. For the real implementation, the system then could be integrated into actual school management system. Furthermore, it could be demonstrated through APIs how much integration might be achieved to enhance student tracking and feedback systems. Next, the DFA system could be tested through simulation in a controlled environment to evaluate its potential effectiveness in managing students' behavior and providing feedback. The simulation would involve creating hypothetical scenarios that mimic student activities such as submitting homework and attending classes. This is to observe how the system might react and log feedback. We will now discuss regarding the students' use case. Here are the students' app cycle. First, it will start with login and dashboard access. This is where students access to their dashboard, which has an overview of their current academic activities and status. Second is real-time feedback. As students engage in their academic activities, such as submitting assignments or attending classes, the system tracks these activities in real time. The DFA engine processes this data and updates the student's current state. Third, receiving feedback. Based on the update state, the feedback module generates messages that are displayed on the student's dashboard or sent via email. For example, if a student submits an assignment on time, they might receive positive feedback like "Good start, keep up with your assignment." Fourth, tracking progress. Students can view their progress over time, including the states they have transitioned through. This helps them understanding their academic behavior pattern and areas for improvement. Fifth, actionable insights. The feedback provided is designed to be actionable. For instance, if a student missed a class, they receive a corrective message like "You missed a class today, try to attend all your class to stay on track." This will encourage them to improve their attendance. Lastly, supportive resources. Alongside feedback, the system can suggest resources or strategies to help students improve. For example, links to time management workshop or tutoring service might be provided if a student frequently misses assignment.
Let's now move on to discuss the final part of the presentation, the theoretical findings and conclusion. Since the development of the solution was beyond the scope of this paper, no actual data was collected as such. However, simulations in JF lab predicted that positive behavioral changes in students because of the system, the theoretical system. The potential enhancement in assignment submission rates and class attendance through this DFA-driven method among the students. And then it also could emphasize the importance of real-time, actionable feedback in maintaining students' academic engagement. So these could be some of the theoretical findings among the students because of the use of the system. And then moving on to some conclusion is that the overall conclusions of the entire system could be this study ties up to the initial motivation and the problem statement that we started with. So we can safely conclude that the implementation of automata could be done effectively in educational settings too, and to modify students' academic discipline too. So theoretically, the DFA system could offer real-time, personalized feedback to improve students' discipline and academic consistency. Some of the future direction could be to integrate machine learning to further personalize the feedback and enhance the effectiveness of educational interventions. So that's all for our presentation on the technical report. Thank you, Doctor.